So far we've worked on multiplication properties of exponents, so we're going to move on now to some division properties. First things first, just want to review one thing here. Please note that if I have 2 to the negative 3, remember that is the same as 1 over 2 cubed. So that means, again, if there's a negative exponent here, it technically belongs, down here. So if I have the following, if I have a to the m over n, just like when I had a to the m times a to the n, you multiplied them, or you added them, rather. In this case, you subtract them. And let me give an actual example, maybe using numbers. If I have 2 squared over 2 cubed, that's the same as 2 to the 2 minus 3, or 2 to the negative 1. Now the reason that works, let's expand this one. If I had 2 times 2 on the top, because that's 2 squared, 2 times 2 times 2 on the bottom, because that's 2 cubed, and I canceled, I'm left with 1 over 2, right? So which is what this obviously is, 1 over 2 to the first power, just 1 over 2. That's why it works. So just like when we had a to the m, you kind of distribute the whatever's inside the parentheses there. Same thing works here. If I have some fraction, a over b, and again, make sure we know that a and b are real numbers here, and non-zero at that, right? That becomes a to the m over b to the m. So if I were to give it a real number, that would look like this. If I had 2 over 3, there we go. That's better. 2 over 3, and the whole thing squared, that'd be the same as 2 squared over 3 squared. And the reason that works is that if I have, like this, 2 to the, or 2/3 rather, squared, that'd be the same as 2/3, right, times 2/3, which is really 2 squared over 3 squared. In this case, we finish up, that's 4/9. So that's why it works. So to review before we do some examples, all we've done is learned some shortcuts. You could do it the long way, write it all out, but we just learned some shortcut rules here today. And please remember again, this is when the base is not 0. So again, if we have division, we subtract, just like when we multiply, we add. And if we have a fraction raised to a power, it's the same as raising the top and the bottom both to that power. Start with example A here, y to the 5th over y to the 4th. That's the same as y to the 5 minus 4, which is just y to the first power, or just y. B, that's going to be d to the 3rd minus 9. Kind of wrote that funky there. Hang on a second. So d to the 3 minus 9, or d to the negative 6th, which is 1 over d to the 6th power. So that's B. On C, we're going to have k to the, let's see here, k to the 6 minus 1. Notice here, we've got a 1 power down here and a 6 power up there, times j to the 2 minus 5. So k to the 6 minus 1 is k to the 5th, and j to the 2 minus 5 is j to the negative 3. And again, we go ahead and write that in standard form, k to the 5th over j, that's not really a j, was it? Over j to the 3rd power. There we go. So taking a look at D here, that becomes a to the negative 3 minus 5 more, and b to the 7 minus 2. So this becomes a to the negative 8, b to the 5th. Again, standard form would mean that no negative exponents. So b to the 5th over a to the 8th power. And E, let's see, we're going to have x to the 4 minus 4 power. And then, so that takes care of the x down. You can cross them off as you go, too, if it helps. We're going to have y to the negative 1 minus negative 5. And z to the 8 minus 1. So, let's go back and deal with this here. X to the 0 power, y to the 4th power, and z to the 7th power. This becomes 1, so I'm going to end up with y to the 4th, z to the 7th. So taking a quick look here at the example number 2, population density here. It says the number of people per unit area during 1 year, the population of Angola was 1.21 times 10 to the 7th. So obviously going to be 5 zeros after that. The area of Angola is 41 times 10 to the 5th. So again, 3 zeros after that. What is the population density of Angola that year? Now, so we write them out. 1.21 times 10 to the 7th divided by 4.81 times 10 to the 5th. Just go ahead and divide off the numbers in front. And then as far as the tens go, we can use our exponent rules. So 10 to the 7 minus 5. So we end up with 0.252 times 10 squared. And again, we didn't ask for scientific notation, otherwise we'd be almost there, but we did ask for it in standard form, so it's about 25.2 people per square mile. On this example, it says during 1 year, Honduras had a population of 7.33 times 10 to the 6th people. The area of Honduras is 4.33 times 10 to the 4th miles squared. What is the population that year? So what that looks like when we write it out is 7.33 times 10 to the 6th divided by 4.33 times 10 to the 4th. So really I'm going to divide 7.33 divided by 4.33, which is going to be 1.69, and that's times 10 to the 6 minus 4, or 1.69 times 10 squared, and we bump those 2 decimal places, and that comes up to be 169 people per square mile. Let's take a look at example 3 here. What is this in simplified form? So we've got to remember a couple things like power to a power and that sort of thing. So when we start out here, we're going to end up with z to the 4 times 3, which is 12 over 5 cubed. So the z to the 12th over 125. So similarly here, we're going to end up with 4 squared on the top and x cubed squared, right? So which means power to a power, so that becomes x to the 6th. 4 squared is 16, so 16 over x to the 6th power. Continuing here, the second part, describe 2 different ways to simplify the expression. Which method do you prefer? So here, you could go ahead and simplify inside first. So getting a squared, so 7 minus 5, so a squared, raised to the 3rd power is a to the 6th. Or you could distribute that 3. So you could have a to the 21st power over a to the 15th power, and then still subtract the 2, like we show here, and get a to the 6th. Now this question gets at some of the toughest on my quiz and test. So let's take a look here. If I raise something to a negative exponent, you still distribute it just the same as you would otherwise. So notice here, we're going to distribute this 3, so this becomes 3 to the negative 2 on top, and 3 to the negative 18, or x to the negative 18 on the bottom, y to the negative 12. And then we move everything around. So let me write that part out for you here. So again, this 3 here, this becomes 2 to the negative 3 times x to the negative 18, because 6 times negative 3 is negative 18, and the bottom y to the negative 12th, because 3 times 4, or negative 3 times 4 is 12. Now you'll notice that these things are in the wrong positions, so everybody's got to move around. So on the top, that's going to become y to the 12th, so now that's a positive exponent. On the bottom, 2 to the negative, to the positive 3 now, and x to the positive 18. And we find that we multiply that out. 2 times 2 times 2 is 8. So on the bottom, I'm going to end up with 8x to the 18th, and on the top, y to the 12th. Same thing they got here, only I think that method works a little bit better. It kind of keeps you in line, keeps you on track. So for the got it there, it's a over 5b, the whole thing to the negative 2. So you go ahead and make that a to the negative 2 over 5 to the negative 2 times b to the negative 2. So you recognize right away that these exponents mean, the negative exponent means they're in the wrong place. So we got to move them. So that a squared, the negative 2 goes to the bottom, become a squared. The 5 to the negative 2 goes to the top to become 5 squared, and the b becomes b squared. Now we can go ahead and make 5 squared into 25, and then b squared all over a squared. And there we go, no negative exponents, and everything is in its standard form. So I can't stress enough how important understanding this one is with the negative exponents. This appears on my quiz and test. This is the most common kinds of errors I see folks forgetting to take that negative with it and then move them to the right position.